We have seen example number 1 and 2 from problem set 6.1. Let us see example 3. It is given that cot theta is equal to 40 upon 9 and you are asked to find cosec theta and sin theta. As before, we are doing by two methods. Method 1 is using the figure. So we have drawn the figure triangle ABC as a right angle triangle in which angle B is 90 degrees. One of the acute angles is theta, so let angle A is equal to theta. Now we know that cot theta is equal to length of the side adjacent to angle theta upon length of the side opposite to theta. The opposite adjacent to theta is AB and opposite to theta is BC. So in the figure, cot theta is given as 40 upon 9. So AB is a multiple of 40, let it be 40k, and BC is a multiple of 9, let it be 9k. Now using Pythagoras theorem, we have to find the remaining side, third. So in the figure, measure angle A is theta and let the side adjacent to angle theta, that is AB, equal to 40k, and let the side opposite to the angle A, that is BC, is equal to 9k. Now using Pythagoras theorem, the square of the hypotenuse is equal to sum of the squares of the other two sides. So AC square, hypotenuse square means AC square. AC square is equal to AB square plus BC square. AB square plus BC square. AB is 40k, so square of 40k. BC square means square of 9k, and you have to add them. So 40 square is 1600k square. 9k square, square of 9k is 81k square. If you add it, you are getting 1681k square. That is the square of 41k. 41k into 41k gives you 1681k square. So if you take square roots, the square root of AC square is AC and square root of 41k square is 41k. You can write here taking square roots of both sides. Now we want cosec theta. Okay, you are asked to find cosec theta. So we can use the definition of cosec theta, that is length of the hypotenuse upon length of the side opposite to angle theta. Hypotenuse is 41k, so this is in numerator, and length of the side opposite to theta. Opposite to theta is BC, that is 9k. kk cuts, so it comes out to be 41 upon 9. This is cosec theta. You are also asked to find sin theta. So cosec theta and sin theta, they are related. Sin theta, from the figure if we find, it is length of the side opposite to angle theta upon length of the hypotenuse. It is the reciprocal of cosec theta. So whatever was in numerator here, that has gone in denominator, and what was in denominator, that is in numerator. So instead of 41k upon 9k, it is 9k upon 41k. kk cuts, so it is 9 upon 41. Cosec theta is equal to 41 upon 9 and sin theta is equal to 9 upon 41. Now, without using the figure, using formulae, we can do this. So cot theta is equal to 40 upon 9. You are asked to find cosec theta and sin theta. Now there is a relation. Cosec square theta is equal to 1 plus cot square theta, that you have to use, equal to 1 as it is plus as it is, and cot square theta means square of cot theta. Cot theta is given as 40 upon 9, so square of 40 upon 9. So 1 upon 1 plus 40 square upon 9 square. So this is equal to 1 upon 1 plus 14 square is 1600, 9 square is 81. So denominator is 1 and 81, LCM is 81. And here you are cross multiplying 1 and 81. If you add it, you are getting 81 plus 16 100 multiplied by 1 gives you 1600. So that is how we are getting 81 plus 1600 upon 81. This step is repeated, it is same. So adding, you are getting 1681 upon 81. If you take square roots of both sides, so square root of cosec square theta is cosec theta, and square root of 1681 upon 81 is 41 upon 9. You can write here taking square roots of both sides. It is always better to write the steps and reasons everywhere. Now cosec theta we found out to be 41 upon 9. To get sine theta, we are using the identity cosec theta into sine theta is 1. That means sine theta is equal to 1 divided by cosec theta. That is 1 divided by cosec theta means 41 upon 9. So that becomes 1. Divide means multiply by the reciprocal. So 9 upon 41. So that comes out to be 9 upon 41. So cosec theta is 41 upon 9 and sine theta is 9 upon 41. That is how both the ratios we have found out. Given one ratio, we have found out two more ratios.